So the central theme of the forum today and of the ancestral health and evolutionary medicine movements in general is that there's a profound mismatch between our genes and our biology on the one hand and the modern environment that we're living in on the other. For the most obvious example of this, and the one that we often talk about, is nutrition. So for the vast majority of our evolutionary history, humans ate primarily meat and fish, wild fruits and vegetables, some nuts and seeds, and some starchy plants. Now contrast that with today, when the top 6 foods in the American diet are grain-based desserts, bread, sugar-sweetened beverages, pizza, beer, and chicken, primarily fried chicken dishes like chicken nuggets. But I would argue that there is another example of mismatch that's not as frequently discussed, but is every bit as important, and that is our stress response system. So this has 2 primary components. There's the sympatho-adrenomedullary system, or the SAS, which is part of the sympathetic nervous system and is primarily responsible for our immediate or short-term stress response. And then there's the hypothalamic pituitary adrenal axis, or HPA axis, which governs our intermediate or long-term stress response. Now these systems are both pretty complex, and we don't have time to go into detail on them today. But what I want you to keep in mind for the purposes of this talk is that mechanisms that are protective or adaptive in the short term can become damaging or maladaptive over the long term. For example, let's say you're a hunter-gatherer and you're out for a walk and you get confronted by a lion. In that case, it's a pretty good thing that your heart rate and blood sugar and blood pressure go up, your muscles tense, and your digestive and reproductive system shut down. All your body cares about in that moment is survival. It doesn't matter whether you digest your next meal or you're producing hormones that will lead to fertility. All it cares about is surviving that immediate threat. But what happens if this system is continually activated, as it often is in the modern world? We're stuck in traffic, we are using electronic media late at night, we're eating an inflammatory standard American diet, we're exposed to environmental toxins. All of these things activate that same stress response, but the difference is the changes that are protective and help us in the short term become damaging over the long term. This constant activation of the stress response erodes resilience and it depletes metabolic reserve. So resilience is defined as the immediate capacity of cells, tissues, and organ systems to respond to changes in physiological need. And metabolic reserve is the long-term capacity of the body to do that. I would argue that the loss of resilience and the depletion of metabolic reserve are key drivers of the modern disease epidemic. And this explains why stress is associated with such a dizzying array of conditions. And this is only a partial list here on this slide. So given this, it should be clear that addressing the stress response is absolutely crucial. It should be part of the treatment for every patient that walks through our door, no matter what their condition is. Now, so far in functional and integrative medicine, the model for approaching stress-related pathology has been based on the adrenal fatigue concept. And this, in turn, is somewhat loosely based on Selye's general adaptation syndrome. And when Selye did research on animals, he observed a progression over time with the stress response. And then later, he didn't really study cortisol or pregnenolone or DHEA, but these hormones were kind of overlaid on his model. And it predicts levels of cortisol, as you see in the figure on this slide. Stage 1, cortisol goes up, pregnenolone and DHEA go down. Stage 2, cortisol begins to fall and can actually be in the normal range. But what differentiates stage 2 from a normal presentation would be the low levels of DHEA and pregnenolone. Stage 3, all 3 hormones continue to fall until they reach exhaustion or failure. Now, raise your hand if you're familiar with this model. Right. It's been the dominant paradigm of understanding stress-related pathophysiology in the functional and integrative medicine worlds for pretty much 3 decades now. But is it really an accurate representation of what happens? Is the adrenal fatigue concept in alignment with the current scientific evidence, and is it the model that will get us the best clinical results, which is perhaps the most important question? I'm going to argue that there are 3 primary problems with the adrenal fatigue concept. One is that many, if not most people with so-called adrenal fatigue don't actually have low cortisol levels. 2 is that even when cortisol is low, it's rarely because the adrenals are fatigued and unable to produce it. And 3 is that adrenal fatigue is not really supported by the current scientific understanding of the stress response. So we're going to talk about each of these in a little bit more detail, starting with number 1. So the assessment of adrenal fatigue has depended on saliva measurement of cortisol, primarily the adrenal stress index, measuring cortisol 4 times throughout the day. And cortisol that's measured in saliva is in the unbound or free fraction form, so it's not bound to a protein carrier. Now, this form of cortisol is the only form that has cell signaling effects, but it only represents about 3 to 5% of the cortisol in the body at any given time. The rest of the cortisol is cleared by several different metabolic pathways before it's conjugated and excreted in the urine. So while free cortisol certainly is the most potent form of cortisol, it's not the best marker for total cortisol production. Since the majority of cortisol is excreted in the urine as metabolites, measuring these metabolites is the best representation of cortisol secretion, as this study concluded. The sum of total cortisol metabolites provides a reflection of cortisol secretion rate. Now, this might be a moot point if free cortisol and total or metabolized cortisol were always the same. The problem is they're not, and in fact, they're often discordant. It's possible, for example, to have low free cortisol and have normal or even high total cortisol. And in fact, this happens in several different conditions, like obesity and insulin resistance. So now 38% of the US population is obese, 2/3 are overweight, so these are obviously very common conditions. Active stress response, also quite common in the industrialized world, hyperthyroidism, glucocorticoid use, and chronic fatigue syndrome. As a side note, it's also possible to have high free cortisol and low total cortisol, and this happens in conditions like hypothyroidism and impaired liver function. But we're not going to go into that in this presentation. Now, in obesity, you would expect to see normal or low free cortisol and then high cortisol metabolites. The figures on the slide here are from a study published in Obesity, and it looked at the relationship between urine and saliva free cortisol and cortisol metabolites and then obesity. And what they found, as you can see in the charts, is that there was no difference in free cortisol levels between obese patients and controls. But when they looked at cortisol metabolites, there was a linear increase in total cortisol as fat mass increased. So check out this test result. This is from a lab called Precision Analytical that offers a dried urine hormone test, the Dutch test. And as you can see here, this patient has very low free cortisone, very low free cortisol, and a flattened diurnal cortisone and cortisol rhythm. Now, these aren't at the levels that you'd expect to see in something like Addison's or true adrenal insufficiency, but they are in the realm of what might be typically called stage 3 adrenal fatigue if we're using that model. If you did a saliva adrenal stress index on this patient, you might expect to see something like this: low cortisol in the morning and all throughout the day, and then a low total 24-hour sum cortisol estimate. But check out the cortisol metabolites in this patient. They are close to 9,000, which is over 2 times the upper end of the reference range, and the total DHEA production is almost 5,300, which is also more than 2 times the upper end of the reference range. So this patient was 420 pounds with significant insulin resistance and leptin resistance. So this is obesity. This is not adrenal fatigue. And the best way to treat this patient and to bring the cortisol levels down may not be to use things to reduce cortisol. It may be to address their blood sugar and insulin and leptin regulation. So this is, we're going to talk more about why this is so important later. What about chronic fatigue syndrome? At first glance, it does appear that studies support the idea that chronic fatigue patients have low cortisol. For example, this study found that average cortisol and cortisone concentrations were significantly lower in patients than in controls across the whole day. So if we stop there, we would think, yes, this supports the idea that chronic fatigue patients have low cortisol. But that study only measured free cortisol. And the same authors, interestingly enough, did a study later where they measured both free cortisol and free cortisone in the urine. And as was consistent with the previous study, they found that there were lower levels of free cortisol and free cortisone in chronic fatigue patients than in controls. But look what happened when they measured cortisol metabolites in the urine. There was absolutely no difference at all between urinary cortisol metabolites between controls and patients. So they had the same total cortisol output. Now, lest you think it's uncommon to see these kinds of disparities in free cortisol and total cortisol, according to unpublished data from Precision Analytical, the lab we just talked about a couple slides back, looking at 2,000 test subjects, of those who had low free cortisol, only 15% actually had low total cortisol. The other 85% had either high normal, or low normal total cortisol. So if you put this a different way, a patient that has low free cortisol in the urine or in the saliva is actually more likely to have normal or high total cortisol. So let's move on to number 2. Even when cortisol is low, it's rarely because the adrenals are fatigued and unable to produce it. The control mechanisms for cortisol production in the adrenal glands reside primarily in the brain and the central nervous system. The HPA axis governs circadian and stress signals in the brain and cortisol output through negative feedback inhibition. So even though the adrenals are what produce cortisol, the regulatory mechanisms are primarily outside of the adrenal glands. And while the production of cortisol by the adrenal glands is important, it's really only the tip of the iceberg. Cortisol is such a potent hormone. The body has multiple regulatory mechanisms for controlling its bioavailability in local tissues. And this turns out to be the most important factor determining how cortisol affects our physiology. So, for example, if we're producing huge amounts of cortisol, but our cells are resistant to it, then we're not going to experience a hypercortisolemic state. It's not going to have that effect on us. So we don't have time to cover all of the brain and central nervous system and tissue-specific regulatory mechanisms tonight, but I do want to cover 3 of them. And if you're interested in learning more about this, I recommend a book by Dr. Tom Williams called The Role of Stress in the HPA Axis in Chronic Disease Management. He covers these mechanisms in detail and several others. I do want to cover 3 of them, though, just to give you an idea of how this works. Oops. Okay, so the first is downregulation of the HPA axis. And what happens here is when we're exposed to stress for a prolonged period of time, or really intense stress, like with PTSD, you see a downregulation in CRH receptor sensitivity. And this is the body's wise attempt to protect itself from the effects of chronically high cortisol levels. But the problem is that that actually ends up reducing the body's ability to produce cortisol, which is an important hormone, of course, in the face of future stress. So this is a perfect example of a change that is adaptive or protective in the short term that becomes maladaptive over the long term. The second mechanism is impaired cortisol signaling. Chronically high cortisol levels will lead to cortisol resistance in a similar way that chronically high insulin levels lead to insulin resistance. And this can be caused by a decrease in cortisol receptor sensitivity and or a decrease in cortisol receptor expression. The third mechanism is decreased cortisol bioavailability at the tissue level. And this can have several different causes. One is increased levels of the binding protein that carries cortisol through the blood. Most of it is cortisol binding globulin. It's also albumin carries a little bit of cortisol. 2 is increase in the conversion of cortisol, which is the more active form of the hormone, into cortisone, which is the less active form. And 3 is the activation of the multi-drug resistant pump. So this pumps cortisol outside of the cell where it can't have its transcriptional effects. Finally, number 3, adrenal fatigue as a concept isn't really supported by current scientific understanding of the stress response. If we want to maintain credibility and increase the acceptance of functional medicine, as James was talking about in his intro, I think we need to align our diagnostic and therapeutic models with scientific evidence as much as possible. And if you look in the scientific literature for adrenal fatigue as a term, as of a couple days ago, there were 10 results. And they weren't the highest quality results either. But if your patients go searching for adrenal fatigue on the web, they might come across the Endocrine Society fact sheet that says adrenal fatigue is not a real medical condition, and there are no scientific facts to support the theory that long-term mental, emotional, or physical stress drains the adrenal glands and causes many common symptoms. Now, I think this is poorly worded because it almost sounds like they're saying there are no facts to support the idea that stress causes common symptoms, which is absolutely crazy. But I think what they mean to say is there's no evidence to support the idea that those symptoms are caused by drained adrenal glands, and I would absolutely agree with that. On the other hand, there are literally thousands of studies, in fact, 18,320 the last time I checked, looking at the effects of stress on human physiology via dysregulation of the HPA axis and the SAS. But in these cases, it's usually high cortisol or a disrupted cortisol diurnal rhythm or cortisol resistance or any of these other mechanisms that we've been talking about that is the problem rather than low cortisol. And even when cortisol is low, it's because of the brain or central nervous system or tissue-specific mechanisms, not because the adrenals are tired or can't produce it anymore. Now, there are some known conditions like Addison's disease or glucocorticoid-induced adrenal insufficiency that present with really low cortisol levels, but these are pretty rare. Addison's affects fewer than 200,000 people a year in the US, and the levels of cortisol that are observed in Addison's or true adrenal insufficiency are orders of magnitude lower than what are observed in so-called adrenal fatigue. So if it's not adrenal fatigue, what are we going to call it? This is not a particularly elegant term, but I would argue that HPA axis dysregulation is more accurate, and in fact, HPA axis maladaptation is probably the most accurate term because, as we've discussed, the changes that occur in the syndrome that we're talking about are an attempt of the body to protect itself. It's actually the body doing something smart to protect itself against the effects of chronically high cortisol levels, but those changes end up being maladaptive in the long term. Another option, though, would be to just name the specific dysfunction that we see. So if the patient actually has high cortisol, we would call it hypercortisolism. If they really do have low cortisol, we would call it hypocortisolism, which just names that it's low, but doesn't imply that it's low because of poor adrenal function. Or we would call it disrupted diurnal cortisol rhythm or cortisol resistance or whatever it is. So why does this matter so much? First, it brings us into alignment with the current scientific evidence base, and this allows us to leverage the vast amount of research that connects stress and HPA axis function and disease. And there's so much fascinating work being done on this. For us to be able to plug into that and converse with other clinicians who are working in that field, I think is really important. Second is that it helps clinicians and patients to better understand what's happening. So if we have this idea that the symptoms are all caused by the adrenals being tired and unable to produce cortisol, there are very few clinical interventions that we have available to us. We don't know much about how to increase cortisol output by the adrenals. And we can, of course, replace cortisol with Cortef and things like that, but it's a pretty limited frame. But if we understand that this is a complex syndrome involving dysregulation of the HPA axis and the SAS and tissue-specific regulatory mechanisms, and it's caused by things like circadian disruption and glycemic dysregulation and inflammation, in addition to the common mechanisms that we talk about, that will lead to a much broader range of treatment options and diagnostic options for that matter. Number three is that related to it leads to better treatment outcomes and prevents harm. So if we see a patient that has low free cortisol and we prescribe something that will increase cortisol levels, and then we find that that patient actually had high total cortisol, there is potential for causing harm. So I think the term adrenal fatigue has served a really useful purpose when we lacked a more sophisticated understanding of the relationship between the HPA axis and stress-related pathology. And there's no doubt that interventions that have been prescribed in this model have helped thousands, hundreds of thousands of people and continue to help people today. But I would argue that as our knowledge has progressed, this oversimplified explanation has become an impediment to making more progress. And an analogy here would be good and bad cholesterol, which was a simple heuristic that was created to raise awareness about the relationship between diet and heart disease. But now as our understanding has grown about the roles of LDL and HDL, it turns out to be a lot more complex than this originally led on. And this oversimplification, I think, holds us back. So I would argue it's time to lay the adrenal fatigue concept to rest. As Max Planck famously said, one of my favorite quotes, science progresses one funeral at a time. So if we want to move forward, we have to be willing to continually challenge our beliefs and let go of them when the evidence doesn't support them. I hope I've showed that to be the case here with the adrenal fatigue concept. So if you're interested in this topic, I'll be covering it in more detail later in a free seminar. I also have a free seminar coming up this spring on myths and truths about SIBO, diagnosis and treatment, which is SIBO is all the rage now. And I've put together a special offer for all you functional forum folks with training on how to approach 10 of the most common health conditions that we treat in our practice, from hypothyroidism to autoimmune disease to overweight, from a functional and ancestral perspective, with diet, lifestyle, supplement recommendations, lab ideas for labs, as well as discounts and free passes for upcoming seminars. So you can check that out at goevomed.com/Kresser. Thank you all for listening, for your time.
Thanks so much for watching, and for more great clips like this, please subscribe to our YouTube channel. I've created a special free video just for you. It's called the 5 Steps to Becoming a Leader in Your Wellness Community, and it'll give you some of the starting points on how to position yourself as the leader in your zip code of your health community. All you have to do is click on the link below.